All right, this is Module 6, Lesson 17, Concept Development. So what I want you to do is have a ruler out, and I want you to use a straight edge to draw a line segment on your paper. So let's draw a line segment that is from 3 to 6. All right, now, so it's about 3 inches long. Now, what I want you to do is I want you to draw a dark point off the line and label it A. So this is step 2. So step 2, you're going to draw a point and you color it in kind of dark and label it A. Step 3, I want you then to take your paper and I want you to fold it on that line that you just drew. So I want you to fold it, and now I want you to press. I want you to kind of rub. You can even use your ruler. I want you to rub and see, oh look, I ended up with a dot on the other side. Now you're going to label that B. So what I just created is I folded along the line and I created a symmetrical point on the other side. So I know you've learned about symmetry in the past. So an example of symmetry, can you fold something in half both ways and end up with a line of symmetry? So you could fold this way and it would be symmetrical. That means it would fold and land exactly on itself. Or you could fold it this way and it would fold on itself. The same with this shape and the same with this shape. It would fold up and fold on itself. But this shape, you could fold it across and it would fold on itself, but you couldn't fold it down, so it would not be symmetrical. So this shape right here, what do you think? So draw a line of symmetry on this point. This would be symmetrical. This would be symmetrical. This would be symmetrical. And this would be symmetrical. So that's our big idea today. It is drawing symmetrical figures using distance and angle measure from the line of symmetry. Okay, here would be another example of symmetry. Knowing that, could you use the grid boxes to draw a symmetrical figure that would fold on itself? So your symmetrical figure would look like that. Here's another example of symmetry, but using the dots. Could you count the dots? So this is kind of like what we were doing in the last few lessons when we were creating those perpendicular lines with the triangles and you were counting over in order to create that perpendicular line. So here's another example of what that symmetry would look like. All right, so back to our line here. So let's now measure the angle. So the angle should be a 90-degree angle, right, that we drew. It should be straight up and down. Now, but wait a minute. Let's mark on the end here. And let's connect these two dots. Now, let's measure our angle. Oops. So our angle looks like it's 80 degrees. And then let's measure it on this side. It measures 80 degrees on this side and 80 degrees on the other side. So our angles are symmetrical, right? Now, if we measured our angles straight up and down, well, that would be a 90. This would cross the line of symmetry here at 90 degrees, right? All right. So this angle over here, this angle over here, and this angle over here, all four of those angles are going to measure 90 degrees, correct? Correct. All right. So the line segments are the same length. The points are the same distance from the line of symmetry. So using what we have discovered about this pair of symmetric points, can you draw another pair of points without folding the or rubbing? Could you draw something that's also symmetrical without folding or rubbing? So let's draw another point off the line. Let's draw this and call it C. So let's figure out how could we mirror or make another line on this side that's symmetrical? Try it out. See what you would do. All right. So did you end up with something like that? So what I used my set square. So using my set square, I moved my set square over and drew a line, but I didn't know how far my line was. So what I had to do is I had to measure the distance from this point to this point. And this measured from this line, it's about 3 inches. So I knew this had to be 3 inches. So that's how I created that line of symmetry using a perpendicular line, knowing that these angles are all 90 degrees. And since the points were drawn using a perpendicular line to the line of symmetry and they are equidistant means equal distance from the line of symmetry, we say that they are symmetric about the line. So this is when it says it's about the line. So it's symmetrical about the line. That's the terminology. All right. So we're going to move on and we're going to actually use our application template. So if you want to get that out right now and come back and check in with me. All right. So what we're going to do with this template page is we're going to continue with what we're doing by drawing symmetrical figures, drawing a symmetrical figure using distance and angle measure. So the nice thing about using this template here is that these are all equidistant. All of the boxes are equidistant. So this really is, we're just playing around with the idea of symmetry. So if we decided to draw a line and call it, we're going to call this our line of symmetry. Let's just go to 5. Let's just go to basically the middle here. And we're going to draw a nice line of symmetry. Let's draw some arrows showing that it's going in infinite directions. Then let's label 2, 5 and call it F. Then let's label 9, 5 G. Now, using my set square or a straight edge or a ruler, let's draw a line, a perpendicular line on our about our line of symmetry. So let's see, 1, 2, 3, 4, 5, 6, 7. So let's just go here in the middle. So using your set square, you can just, now we have 1, 2, 3 units, right? 1, 2, 3 units, correct? And let's label the top of this, let's label this E. And let's label this, I don't know, H. All right. Now what we're going to do, so we have a perpendicular line, we know because we used our set square. And we measured, we counted the units. So if we decided to fold this paper, they would fold up on each other. They would be symmetrical. Now let's connect line EF and FH. All right. Now we can also connect EG and HG. Now this is not perfectly symmetrical. This is almost like a kite. If we had brought it out here more, our G out here more, it'd look more like a kite. But it's symmetrical, folding it on top of each other this way. On top of this way, there is a little bit more here because this is 1, 2, 3 units. This is 1, 2, 3, and a little bit more, right? Okay, so what else could we draw? So that's essentially it. I mean, you could now we know this is a 90-degree angle, and then we could set out to find the measurement of this angle. It looks like it's 85. And this is about, so it's under 50. So, but we know they have to add up. If this is 90 degrees, these have to add up as well to 90 degrees. Okay, I went back and remeasured using my protractor and realized it's 45 and 45. And then this angle is 90 degrees. All right, on the bottom, let's draw another line of symmetry. And this is 12, so let's go 10. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units, 8 units, 9 units, 10 units. I got a little squiggly there. Okay. I'm trying to make my line thicker. All right, so now we're going to make, let's make an infinite line of symmetry. Then let's plot a point at, let's say, 2, 8, and let's label it E. And then, so that's 3 units, right? 1, 2, 3. Then let's go below. 1, 2, 3. Let's label that, I don't know, H. Then let's come 2 units in label that F, E, F. And then let's label 10, 5 as G. Now, let's see about connecting some of the points and seeing what we get. What figure we get. Okay. All right. Well, that is a fun shape right there. Now, if we folded it this way, it wouldn't be symmetrical. But if we folded it up against itself, it would be symmetrical, right? We could measure our angles using our protractor because we know our angles have to add up to 180 degrees. This one looks like it measures to 130. So if this one's 130, it's going to be, if this is 130, what is this angle on this side? That's right, it would be 50 degrees because it has to add up to 180 degrees. So this one would be 50. This one would be 130. So the angles here. All right. This looks like it measures about 30 and 30, which would give you 60. So 30 and 30 is 60 plus 130 is 180. And in order to make a perpendicular line across the line of symmetry, we know this would be 180. So if across here, and then we know this because this is a perpendicular line, this angle would be 90 degrees. If this angle is 90 degrees and this one's 50 degrees, what does this angle have to be? Remember, it has to add up to 180 degrees. So this would be 30 degrees. 30 degrees. So that's how all of this is related. And this angle would be the same as this angle. And this angle would be the same as this angle. All right. So that is essentially the big idea. So for your problem set, draw to create a figure that is symmetric about AD. So you're going to make the exact replica of this on the other side. Draw precisely to create a figure that is symmetric about HI. So you're going to use this line here as the line of symmetry, and you're going to make another figure about this line of symmetry here. Then on number 3, plot 3 non-collinear points. Now, non-collinear would be going like this. So linear, so if it's collinear, that means that means they share the same line. Non-collinear would be it doesn't share the same line. So you're going to go back to this idea here. So you're going to plot 3 non-collinear points, D, E, and F. You're going to have D, E, line DE, line EF, and line DF. Plot a point G and draw the remaining sides such that quadrilateral, so it's going to be a quadrilateral, DEFG is symmetric about DF. So DF is going to be your line of symmetry. So these will have to be about your line of symmetry. Then Stu, which is short for Stuart, says that quadrilateral H, I, J, K. So here's an example of a quadrilateral with lines that are non-collinear, is symmetric about H, J. So this is symmetric about HJ because IL is equal to LK. Use your tools to determine Stu's mistake. So you're going to use your tools to see why he is or is not wrong. But it looks like he did make a mistake. So you're going to figure that out. Your exit ticket is draw 2 points on one side of the line below and label them TU. Use your set square and a ruler to draw symmetrical points about the line that correspond to TU and label them VW. So your homework, you're going to create symmetrical figures, and the same is creating that quadrilateral. All right, I think you're ready. Come back and check your work for Module 6, Lesson 17, Problem Set Debrief.